Go back into our triangle stuff. We are going to solve the triangle. We're given a little bit of information.
Me too.
Okay. There we go. That one. Okay. Trying to figure out where I was in my notes. All right, y'all. Locking back in. So we are asked to solve the triangle. We're given side C is 2.48 feet. Angle beta is 102 degrees. And gamma is 54.6 degrees. So when we have something like this, I highly recommend that we draw ourselves a triangle. It does not have to be to scale. You can draw an acute triangle. We do see that we do have an obtuse angle here, so we can draw an obtuse triangle. It genuinely does not matter what your triangle looks like. We're just using it to help us with our relationships. That's a really mouse straight line. I am going to give us kind of an obtuse triangle here. I'm going to give a less obtuse. There we go. Boop. So here's our triangle. And we do know that our obtuse angle is going to be 102 degrees. So this is going to be his point B, so that our angle beta, 102 degrees. That means that this guy over here, this long side, that's our side B. Then we get to pick some of our other points. I'm going to name this guy A up here. And let's see at the bottom, it genuinely does not matter which point we put where. I do not care if we draw it to scale or not. Point C gets angle gamma. So this point over here is going to be our 54.6 degrees. And side C, which is the one that's across from angle C like this, this guy is our 2.48 feet. So the pieces that we need to find are angle alpha, side B, and side A. Those are the pieces we're trying to find. We need to make sure we get all the pieces. When it says solve the triangle, it means find all the pieces. We need this angle, this side, and this side. So what do we notice? The alpha. Yeah, I was gonna say, I do also have them up here if you ever forget the names of them with their little symbols. I think that there's also one up on that side as well with the Greek letters and what they're called. Bless you. So yeah, we know that the angles in a triangle are all gonna add up to 180. So we can absolutely find alpha right off the bat when we know that our 102 degrees plus our gamma, which was our 54.6, plus our alpha is going to equal 180 degrees because it's a triangle. That is part of the definition of being a triangle. So what is angle alpha going to be?
23.4.
23.4 degrees. Please make sure you put the degree symbol on your degrees. Otherwise, you've magically told me it was radians.
So we don't. So if we do that, we don't get points.
I was gonna say I wasn't petty about it on this test, but it's an important thing. It's an important thing. There's a lot of college professors who would straight up mark it wrong without that. You're welcome. Okay, so now we know angle alpha. And we've got to find our sides. We need to find side A and we need to find side B. So we've got that one done. This is when we're going to use our law of sines that we were working with last week that we got on Friday. Okay, where we have that the relationship is the same from side A over sine of alpha to b over sine of beta and c over sine of gamma. These relationships are the same. We are never going to do all three at the same time, ever. We're going to pick the two that we want to work with. So, which ones should we start with?
Alpha and beta.
Beta.
We can look at beta. Which one do we need to for sure use?
Alpha.
Which one do we know both pieces of?
Gamma.
Gamma. We know side C and angle gamma. So that means I know this whole fraction. I can build that one as my 2.48 feet over sine of 54.6 degrees. And now I know my angle for alpha to find my side A, or we can do our angle for beta to find side B. It doesn't matter which one we do, but we're going to have to do both. So I'm going to go ahead and do beta because I heard that one first, the last one. So we know that side B is going to be over sine of beta. Beta is 102 degrees. Do we know what the value of sine of 102 degrees is?
I don't think so.
Not at the top of our head. That's not a unit circle value. So what can I do to get B by itself over here?
Multiply by something.
Multiply by our sine of 102. I'm going to multiply by our denominator, sine of 102 degrees times sine of 102 degrees. So we're going to get that B is a hot mess of a fraction, 2.48 times sine of 102 over sine of 54.6. Gross. We want to get that as a number. Yes. Okay, and we're going to type that in the calculator. Make sure you're in degree mode. Since we have all of our angles in degrees, we got to be in degree mode. And we can type this whole fraction in the calculator, and we're going to get that our B, we're going to go 2 decimal places since we already have that for feet. We get 2.98 feet. So now we know the dimension of side B. We still need to find A though. We've got C and gamma. I've got B and beta. I've got alpha. I just need A. It's our last piece on this triangle. I could use B and sine of 102. We can. It's valid. I'm going to stick with my given one just because we know for sure that one's locked in. So when I'm setting up to find alpha, I'm going to keep using... We good, guys? Anthony and Lena, we good? Okay. Just checking. Making sure. We've got our 2.48 over our sine of 54.6. And to find our alpha, we're going to set, or to find our A, excuse me, we're going to set up as A over our sine of alpha, our 23.4. So again, we're going to follow this kind of same process. We're going to multiply by our denominator to get that our side A is going to be this hot mess of a fraction with our 2.48 times our denominator, that's our sine of 23.4. Hi. Awesome. Shoot my hand. Coco. So our sine of 23.4, I don't think it's an oohing situation. Over our sine of 54.6. So what do we get for side A? 1.21. Just double checking things before I confirm things. 1.21 feet. So now we know side A, we know angle alpha, we know side B and angle beta, and we know side C and angle gamma. There we go. Our 1.21 feet. Okay. Questions on this one? Okay. So here we're being given a triangle. It's just writing it in a very slightly different way, y'all. It's just a little bit more simple-y. M angle A, that just means the measurement of angle A. Angle A is also known as alpha. What's up? I was gonna say, we've got degrees in minutes. So we got things that we can do. We just gotta be careful with stuff. Yeah. We can leave it as minutes for now, and I'll show you what we do with it, like, as we get closer, okay? So when in doubt, I always draw a picture. I don't worry about scale too much. I'm just gonna draw myself a little triangle. It just helps me keep track of the pieces that we have and the relationships. Trying to do it in my head is really, really difficult. So I'm gonna put the heck. Apply the filter to the words coming out of your mouth. I do record. This say the mic is right here, my friend. I'm gonna name this point over here our A. I'm gonna do this one a C. It genuinely does not matter if your points are in a different spot than mine. It does not matter. So we know that our measure of angle A, that's also known as our alpha. That's this guy over here. That's our 23 degrees and 12 minutes. Our angle C, that's also known as our gamma. That's our 64 degrees and 36 minutes. And we know that side C, which is opposite to that angle, is 5.7 meters. So what's our thoughts? We can do A first to find side A. Absolutely valid. Side A is this guy over here. How would we find side A?
Like transforming to 50 degrees.
Mm-hmm. Our 5.7 meters over our sine of 64 degrees, 36 minutes. Ugh.
I have a question.
What's up?
When do we know when we're supposed to either put like the at the top or like put like this?
The piece we are missing
Right.
should be in the numerator.
Okay.
So since we were looking here for side A, we put our sides on the top. If we were trying to find the angle, we put our angle on the top, so we'll put the sign on the top if we're trying to solve for an angle. So if we're looking for alpha here, we're gonna set up our other fraction, or our side A, because we know alpha is our sine of 23 degrees, 12 minutes. So again, we can get our A multiplying by that denominator, and this thing's gonna look like a super hot mess here for a second. Because we have our 5.7 times our sine of our 23 degrees, 12 minutes. Thank you, my dear. Over our denominator that had our sine of 64 degrees, 36 minutes. Can I just type this in the calculator as sine of 23.12? No. Yeah, I was gonna say there's 60 minutes in a degree, right? So it's 12 out of 60. You can put it in the calculator as our 5.7 times sine, and it opens our parentheses automatically, and we don't even have to like simplify stuff. We can put our 23 degrees plus 12 out of 60. It's super gross, but we can do it. Sine, and we can do the same thing down here, our 64 degrees and our 36 minutes out of 60. So you could also convert this to decimal. It's 100% the exact same thing. If you convert 23 and 12 minutes back to decimals for degrees, you will get the exact same thing as 23 plus 12 over 60. And you can type it in the calculator just like this. Yep, you should get 2.49. So side A is going to be 2.49 meters. So it would be, there's 60 degrees, or 60 minutes in a degree, and 60 seconds in a minute. So it would be over 60 times 60. So it would be 360. So you could do it the same way. You could have three fractions are 23 degrees, 12 over 60 for minutes, and then say it was 24 over 360 for seconds. So you can do it just like that because there's 60 degrees, or 60 minutes in a degree, 60 seconds in a minute. So 60 times 60. So you don't have to put it to decimal. You absolutely can. It's totally valid that way as well. But that gives us our side A of 2.49 meters. What can we do next? We can find beta. Again, I know all the angles inside a triangle add up to 180. So we know that our 23 degrees, 12 minutes, plus our 64 degrees, 36 minutes, plus whatever the heck beta is going to be, needs to equal our 180 degrees.
Can you rewrite 180?
Yep.
179.
Yep, we absolutely can write 180 instead of being as 180 as 100, whoa, not a pen. 179 degrees and 60 minutes, if that helps you. Because that still means 180 degrees. It's just now got pieces that we can subtract from to help us find beta. What is our angle beta going to be?
92.
So we're 92 degrees. And how many minutes? Close.
12.
12. Because 60 minus 36 minus 12. So angle beta is 92 degrees and 12 minutes. Same vibe as this guy over here. Find side B. Same process. Find side B. Now that we know beta.
23 plus 92, 12 divided by 100%.
On side. What do we get for side B? 6.3.
Uh-oh.
Let me see. Is this girl? If you push up, I can see it still. Even if you cleared it, unless you did a full reset, I can still find it. All right, so we should get about 6.3, maybe 6.31, depending on where we round. Meter.
I don't know.
Gimme.
It's up there.
Not as decimals. We gotta do the little fraction things. Unless you convert it. Wait, no, you convert it.
I think I got the
It's Monday.
denominator wrong. I think. I'm in degrees.
You're in degrees. Oh, you used C and alpha, not C and gamma. Okay, you put this guy in this spot.
Oh.
Okay, so that's what's going on there. So make sure we're setting up really carefully. Put C and gamma together. Okay, we should get 6.31. All right. Okay.
They try to cast me as a
All right, 1 second. Okay. So we're gonna start getting some more like context-based problems.
What's a ramp? Oh, okay, never mind.
It's all triangle stuff. So this is saying that the side view of our ramp is an oblique triangle. Oblique triangle.
Oh, I forgot what that is.
What's the meaning of oblique?
Oblique just means not right.
Like my obliques.
Oblique means angled. So the oblique muscles are because they're slanted. So it just means not right. They're not at a 90 degree.
So they're related.
They are. Because your oblique muscles are slanted. I think. I don't know. I'm not an exercise person. But what this is telling us is we're going to have a triangle. This is our ramp. This is the triangle they're giving us. That part of that is because I'm bad at drawing straight lines. Thus why the art is never the problem. It gives us the vibe of the question, not necessarily anything else. So they're giving us triangle DEF.
I'm not one to judge. I'll just ask questions.
So I'm going to put, we got point D, point E, point F. I'm putting them like this. So this angle for angle D is our 42 degrees. Angle E is our 23 degrees. And we know that side E is 19 feet. So first thing we're asked to figure out is side D.
If it's just telling us to find B, we don't have to find anything else.
We do not have to solve the triangle. We're trying to find this side.
So it's gotta be sign of a. Are we still using time on this?
Mm-hmm. We're using law of sines.
Sine of
So how are we going to set this up? Are we going to have sides on the top or are we going to have angles on the top?
sides on the top.
Sides on the top because we're trying to find a side. So we're going to set it up with our side E of 19 over our sine of 23 degrees.
Oh, yeah.
That's set equal to side D.
Oh, we're setting equal.
I'm setting it up first.
Oh,
I will always write it
okay.
without doing operations on it first because that's how we make mistakes. So side D is over our sine of 42 degrees. So how do we figure out the length of side D?
Multiply by sine of 42.
Multiply by sine of 42.
32.
Mm-hmm.
Whole numbers or
Let's see, let's go 1 decimal place.
32.5.
32.5 feet. So this guy is 32.5 feet. So a lot of times when they're giving us a problem like this with our ramp kind of situations, they're also going to ask another question. So think of this as like a ramp over a staircase. So this might be like stairs here, so they couldn't measure all the way to the bottom. So what they're asking us next is to find the height of the ramp. Yes, dear.
Okay, so I drew mine when side D,
Mhm.
yeah, side D would be the, like,
Are you sure?
oh wait, never mind.
I was gonna say, because it's not a right angle right here, because if we were to figure out what this other angle is, it's definitely obtuse. That's gonna be 115.
115.
Yeah. So we know it's not a right triangle. So what we're trying to figure out now is we're looking to figure out what this height is.
Here comes some more math.
No, aren't those angles somewhere at the bottom?
They are.
What is that?
So we know that we just talked about this one as being 115 degrees. So this guy is what?
65.
Mm-hmm. So we know that this one is angle 65 degrees.
What if we draw our triangle differently? Then we get different answers?
Side. Maybe we just do side.
Okay, hold your thought for a second. On ones like this, a lot of times we will give you a picture or we'll tell you specifically how to do it. It's why I labeled them specifically like this. Yeah. Or it'll say the angle from the ground and the angle from the ramp, and it'll give you the context to make sure we're talking the same places. So, how could I figure out H?
Oh, sine of some over. Wait, sine of 42.
If we want to figure out what this height is,
Right. But the 19.
I now know this side.
Right.
I know this angle.
Correct.
I know this angle.
Right. Sine of the other.
Just because it's a right triangle doesn't mean we can't still use law of sines. So we can do our law of sines
Yeah.
to get there. Or you can use like an inverse triangle and go back previous chapter.
So we can do sine of.
But I feel like we would rather do it this way. Because to find H, our height, its relationship is with 65 degrees. Sine is 65 degrees. What other piece do we know in this triangle?
Side D.
The side D, which is 32.5. What angle does 32.5 go with in that little triangle?
What the heck?
90.
In this triangle.
Oh.
We're trying to figure out H. So it is in a relationship with 90. So we can put sine of 90 degrees. And then the process is 100% the exact same. Our multiplying by sine of 65. And we get 32.5 divided by sine of 90.
Wait, that one we got multiply.
Mm-hmm.
4.25.
Yep. You can also do this as our sine of 65 equals our opposite over hypotenuse, h over 32.5. You can do it either way. Either way is fine, and we should get to that height of this ramp is 29.5 or 29.49, depending on where you're at. Okay. That is how high this ramp is. Because what this is if we had like over a staircase here, so they couldn't actually take our ramp down straight 90. They had to put it like propped on stuff, and they're trying to figure out the whole thing on length and how high up they're going. Okay.
So if I'm getting this right,
Mhm. Mhm. Mhm.
So how do we find out that D, like side D or side H are like?
So we found side D from knowing these angles and using our law of sines.
Right.
And then we connected this guy straight down because this is not a right angle.
Right.
And we wanted to know how high this was from the earth.
Right.
So that was what we were asked to find.
Okay.
That's this question done.
How do we know, like, how do we connect them? You know, like, oh, that's what we should equal it to like find the height.
We just have to look at the little triangle and set it up again. Or you can either do our opposite over hypotenuse, or we can do law of sines again. Either way is fine. Okay. So we're gonna get a little bit more story-y. I won't make you write it then. All right. So these are gonna be the next two problems that we do.
So it's just that.
So I was gonna say we're not gonna get through all of them right now, like this thing. So, but I'm also not gonna let you do that one part for you. I don't want it to be very Very will throw up every now and then.
You're on fire.
They will come back.
You're fire.
All right. So what this is, and this is a real thing that happens in like rural Alaska. They have these fire towers where people just go and live there for like 4 months in the summer, and like their food gets dropped in by helicopter. So like their job is to just be there and live in the woods and watch for smoke. That's their whole job. And so, I mean, you don't get to like talk to anybody, and you have like no internet except for satellite phone. Like it's like books only. Because you are in the middle of the woods. Valid. I was gonna say, if you just say, I think it's called Firewatch or something like that. Like, there's a couple of TikTokers that I follow that do that. It's pretty kind of cool, actually. So what it is that I have children, so no. I am also very much technology dependent.
We see her one day in the forest.
So if we have Tower 1 and Tower 2, they are on an east-west line. That just means they are equal this way and are 5 miles apart. If you do find one of these Firewatch people, they have all around the edge of the room, it has the degrees of a compass, like around the windows, so that they can find where things are on angles. And they spot a fire at north 27 east. So Tower 1, meaning looking north-south here, they spot a fire at north 27 to the east. So this is fire. I'm going to call it F for fire. Tower 2 sees the same fire at north 32 west. So they go north, but this time they went to the west. They went this way. $32.
I don't know, like, why it's that thing.
Slightly more nouns, please.
Like,
Which thing?
why is not the other one? Or what they saw on the other side?
Oh, because they went to the west and not to the east. So this is 32 west. Never eat soggy waffles.
Oh, never mind.
Okay? So what they want to know, and the answer we're asked to find, is the distance between Tower 1 and the fire. This distance.
Oh. Can we find like? Can you like see like what they equal? What the angles?
What's this angle going to be? Bless you.
Which one?
58.
What makes it say that?
Oh,
So why did it go?
doesn't it make 90?
It makes 90. These guys are directly east-west from each other. This is a 90-degree angle. So 32 degrees and our 58 makes that be a right angle. So what's this angle over here? 63. Oh, start picking a different color. 63. So what's this angle up here? 59. So then, when we're trying to figure out that distance, how are we going to set this up? Law of sines. More specific.
Can we use sine of like 58? Make the E?
Mm-hmm.
5 over sine of 59.
Our 5-mile distance over our sine of 59 degrees
Like equals D
equals our distance d
over C.
over sine of 58 degrees.
So it still works. It's the same thing.
It's the exact same thing. It's still all sines.
Okay, so we got it's calm.
It's just putting it with words. So what is the distance between Tower 1 and the fire? What do we get? 2 decimal places.
4.95.
Mm-hmm.
He's correct.
4.95 miles. Okay, so the bearings and the story problems, they're not brutal.
Slow call.
They will be on
Exactly.
I was gonna say, it's like we'll work through some more. We've got a few more on that page that we'll work through tomorrow. I was gonna say, we're also gonna talk about something specific tomorrow. There's a video, a couple of videos I have linked on the Canvas page that gives some really good animations about what we're gonna talk about tomorrow. I recommend watching them. I do also have a visual aid to help with it because it's kind of weird. But we're gonna talk about kind of a weird case after we do the story problems tomorrow. So I recommend it, but if you wanna watch them afterwards, that's okay too. What's that? What's that? I am doing my grad school with IU. I did not go in person to IU College. So if it is a question about the physicality of IU Bloomington, I have no answers.